Okay, I hope the camera is working for now, because I think it didn't work until now. At least we have a screen recording. So we're going to continue with DOM and pretty much the stuff that we've already seen with it. The few things that I forgot to mention. First of all, if you're dealing with DOM and you're dealing with elements and the visibility of your site, I forgot that there is this very useful website that says the websites need to look exactly the same in all browsers. So yeah, that's the site. There are many such single-purpose sites. I have one too. I'll show it to you in the end. So that's one thing to remember. The other thing to remember, actually, with all the demos and talking about node lists and HTML element lists, I've missed out. Actually, I'm not sure if it was clear that these are two different JavaScript elements. That the node list, I think, is expected to have specific nodes, and HTML element list is expected to have specific elements that are collected. So these are two different collections that return from two different functions, and they do look like arrays like we've seen, but they don't support all the stuff that arrays really supports. So I don't think this demo was good enough to demonstrate it, and I don't think I was clear enough about this, but not all the array prototypes methods are supported by those lists that are returned by DOM operations. So like we saw, we can interact with the DOM with those DOM methods that are through HTML elements that we can take into our variables. So this is pretty much something we've seen. So I don't think there's going to be new in this demo right now. Here we have a few more scripts to handle. Okay, just a minute. So we have here a separate JavaScript, unopposed to what we've seen earlier, and we have a self-contained auto-running anonymous function that is implemented here. So actually we have a script that runs automatically when this JavaScript gets appended to the page, when the page loads, and it gets rendered and immediately gets executed here. We have an internal function. This structure is, by the way, also good if you want to keep everything under, basically everything is under a function, so you don't really have any global variables. You have variables which are relevant to your script, but they're actually inside a function. So everything here will be running inside this scope. It's healthier like this, not to contaminate your page with global variables. And a good way to do it is to wrap them like this with a function that gets executed. And everything that's done inside here is actually referencing those variables. So it's all kept in one closed circuit. So we're receiving here the button and the list. So the button by ID and the list by ID. So we have these two elements. This is the button and this is the list. Then we have a function that formats our time and returns some nicely formatted string of the current time. So we are receiving, we have the current date every time, and We're formatting a string here that will show the current time with a nice padding zeros. And we're interacting with the button that we've collected up here and adding an event listener that every time we click the button, we are going to run this function. So this notation, which is almost very close to what you can do with, for example, with jQuery, allows you to assign a click to the button, click event handler to the button, which is actually this inline function. So every time we're calling it, we're getting the time as a string here, which is returned from this function. We're logging the time to the console, and then we are appending it into the HTML. So the inner HTML, as I mentioned, is the internal HTML of the current element. So the list is this one. And we are appending into its inner HTML a new list item which is inline here, just as a string. So every time the button is clicked, we're appending a new element. It's not well formatted, actually. And also logging it here. Yeah. So one thing you could do when you're holding into an object, into a variable that holds a specific element that you've collected from those operations, you can start traversing the DOM. That means that if you are standing in a specific element in the hierarchy of the page, you can go up to the parent, you can go to the children, you can go to siblings, and that way you can actually scan and traverse the DOM yourself. And there are a few functions that help you to do this. For example, the parent node will return the parent of the current node. Document is, of course, the upper document that doesn't have any parents. That represents the HTML element, but it's actually in hierarchy under the window object. And then we have specific element. If we've collected a specific element, we can get to the child elements of this, the direct children of this element by child nodes. Like we saw actually in the demo previously, that you could also have nodes that are actually just textual white space between the nodes. They would also be collected, like line breaks and tabs, that those also can be read. So let's see it just quickly. All right. So we got a list of the Academy trainers, just in a div, an unordered list with a few items. Each one have a strong, bold text, then some span. And we got a few scripts down here. I think this is the one that interests us, the node traversing. DOM traversing. So what we do here is actually print some information to the console. First we get the list, and we print its element info, which we'll call this method. Just print out each of the nodes. We got the node itself, and we get the child nodes of this current node, and for each of the child nodes, we print out the node name. So we do this twice, first on the list of, that we have in the page, and then we print the information of the document body node, which is the topmost
HTML body representing our body of the HTML. And if we explore what's happening in the console, let's run the page again. So this is what we get. We are only printing out the content, the child nodes of each of the list items. So we have the UL itself that we printed, then we print the number of nodes, and then we go through each of the child nodes, and we can see that each of the list item nodes has what we call a text node, which is just plain text. Actually, we're printing just the nodes themselves, not the list item contents. So we have some text between them and list items. And I suspect, just a minute. I suspect that we get these white spaces here represented as empty, as text nodes. Sorry about that. We could extend it to see the inner HTML of each of these elements and see what they contain, or just debug it for a sec. This is the upper body of our document, which we can see also has some texts, which again I suspect contain not much, because we don't have a lot of text lying around the document. Then our div, which contains the list, but we don't traverse any deeper than that. And the two script elements between them, texts again, since they are constructed with some empty strings, white spaces between them. And that's it. So other ways to get through our nodes. We can get not just the collection of all the children of the current node. You can also access specific ones, like the first and the last child. By the way, when we get a list of nodes which are children, we can, like we saw now, we can go through them in a loop, or we can just tackle each one of them by a specific index, like it's an array of elements. Although we saw last time they're not really arrays, but they do implement some of the characteristics of arrays. So we have the first and last child, and we have the next sibling or the previous sibling. There are two notations for that. Then we can go, once we have an element, we can go through up or down to specific children. I think this demo traverses a little bit more, a little bit deeper. So again, we have the same list. Just to see which JavaScript file we're supposed to see here. Sibling first, last traversing. So here's our function. It's more concise and small. You can see that we're starting with the document element itself, and we're calling traverse element, which is this function, which is recursively scanning all the nodes in the document. So we have it here. We're printing, we're trimming out white space and textual nodes that we saw the last time, and we're printing out an element. And then we're traversing through, we're just calling the function again for each of the children. So we get the first child of our current element, which is here, and we are first printing it out, calling the function recursively, and then going to the next sibling of the child, so that we traverse all the children like that, one at a time, until we get to a child which returns null. That means the next sibling does not exist. And what we get as a result of that is a printout of all the elements in the document recursively. So that's one way to go through all of them. That's pretty useful. Now let's see a few ways that we can make changes and manipulate. So we'll see that we can create new elements, we can remove them, and we can change their properties. So we'll see also a few examples of that. So we saw one way that we can manipulate it once we get the HTML itself in a string, and we can add elements to it just by changing the HTML manually. One option to create elements is to use the document create element method that will create an element with a specific tag name, and it will return it to us. So we can see here that if we're creating an element of type list item, we saw last time the method instance of that tells us what kind of object this is, and we see that it's an HTML list item element, and it also returns HTML element, which is the higher base class of it. But if we check, for example, if it's a HTML div element, it will return false, naturally. And creating the element is not enough. It just creates an instance of it, but this element is not yet on the page, so we'll need to append it somehow. There are a few methods that actually append elements to the page or to the document or to the other elements, wherever you need to place it. So we can see here that we're creating a list item. First we're creating a list with a UL, and we're getting it here in a variable that represents the list, and we're creating a list item which will represent one item. And first we're appending the list item to the list, and then we're appending the list itself to the document body. That's the way to do that. Let's quickly see it live. So we're creating here some boxes. We have styling to define what a box looks like, which is a div with some properties like height and width, and again, looking nice with rounded corners. And we have some coloring effect also through CSS by alternating the colors by their position in the document. So if it's the first, it could be one color, the second, another, and so on. We have here the basic color is black, but whenever we are on an uneven box which is added, we're just changing the color to light blue through CSS. And that's it. We have here a text box input, which will tell us how many boxes we should create. We have a link that should generate them, and we have a div to contain them, and we have a script, which is this one. So again, what we see here is that we are assigning an event listener to the click of the click event of the link, which will direct it to this event handler, this one. We're getting the content div that will be the container. We can see here that we do two things. First of all, we're going through all the children of the div and clearing them out. So as long as the div has a first child, or any child in that matter, we're just removing it from it. So we're using the function removechild that will take the div and just remove its first child. As long as it still has children, this while loop will continue. So we're just quickly scanning them all out of it. Then we're getting a count of how many boxes the user wants to create. And we got here a default value of 5, I think, when it's empty. And once we got this count, we're just going through and creating div elements, giving the div a class, which will get it, which will give the additional CSS that we just saw, and we're appending it to the content div, taking the div and calling appendchild on the content container of it. And the smashing effect, let's put something. You can see that whenever we put here a new number, this div, which contains these boxes, will be cleared out from children elements, and then a new set of children elements will be created and appended to it. If we're empty, we should have some default of 5 boxes. Okay, so far. Okay, let's move on. So appendchild, like we just saw, just appends an element to the document or appends an element to another element as a child. We can also specify where we want to insert this child, because not always we want to build things in a serialized way where we always stick things in the end. We can also insert them before a specific element or after a specific element once we have an understanding of the structure and we understand where we want to add this child element. We can do it more precisely. Yeah, it's mostly demos today, which is okay. We are here. So let's explore first what we have to know what to expect. So pretty much the same structure. We have an input, which will be our text box. Then we have a link, which is clicked. Then we have a unordered list and our script. So when we explore the script, we have the click event on the button again, which will give us a named add name button. So we have that here. So we are getting the content from the text box, just to see where we retrieve that. So we get the text box and we retrieve the inner HTML of what the user has entered. And what we're doing, actually, we are holding an array here. We're creating an empty array which will contain the texts which the user has inserted. And we are searching for a place where the name in the array is greater than. So we are actually, once we insert things like numerical values, we'll get an array here, and we're manually inserting an element into the array by using splice down here, which will result in creating actually a sorted array in this case, so that we'll determine the position this I is counting until it finds the right place to insert our element into the array. So we determine the position of where we're going to insert our node. The name item is the node that we are inserting, we can see it here. So this is a general list item node that we're creating. And down here, we're cloning it. That's one way to just regenerate a node that you have already created, so that we'll have a copy of it and insert it to the document. And we're appending it to the list, which is the container at the position I. And this is the function that actually does that. Just determining the position. We have here some safety measures so that if this thing is not containing any valid value, it will become, we'll put it to before as a 0 value index. And we're just inserting, using the insert before on the container node, this one that we find through the child nodes in a certain position. So once we have a certain position that we've determined first in the array that we are generating, we are finding the child node at the certain position that we have already found, this one, and we're inserting our newly created node just before the node in the array. So the result of all this messy stuff is that we should be getting a sorted list here. Let's try it with numbers first. See how it handles text. Question? So that's how this works. So we're getting an ordered list here, which actually reflects what we have in the array that we're maintaining. As we can see, it's printed out every time, also to the console. So we determine where to place it, put it in the array, so we'll have actually a follow-up instead of traversing through the entire HTML list. We'll just have a reflection in a quick array that we can keep sorted, and it will help us find out where to insert the next element. We just saw an example of removing elements as well, just using the removechild. So once you have an element, you can remove it quickly using removechild, which will delete it from the DOM. So let's see what we're expecting here. So again, we got some styling for div boxes. And we have an input, again, to generate. We have a link that will handle it, and we have some script. What we can see is that we're generating a div using this HTML template. So we have a div with a certain class. This thing is just written as HTML as a string very easily. And each one of those contains a link with the letter X that will act as a close button and also has a certain class. So once we have a click event, we're on generating boxes button click, which will take and create our node. We can see that, but it does the same way that we saw just now. And we're getting, where is that? So we have all the elements with the specific button close, which is this list of buttons that we're generating in our boxes with this class. So we're getting all the elements by class name. And these are all the close buttons that we have So once we add those boxes, we're attaching events, click events to each one of those buttons that will do the remove box, called the remove box, which will, in the context of the event, this will represent the current node that was triggering the event. So we're getting to the parent node, which is the div, and then the parent node, which contains those divs, and we're removing from it the parent node, which is the div containing the current X button. So this here will represent the X that was clicked. The parent is the div, so we are removing the div itself from the parent of the div, which may be any container of it. So it works like this. Let's generate a number of boxes. That's pretty much like we did previous time, just that these X buttons are close buttons. So whenever I click one, it will remove the current button. They'll get recolored because the CSS is reevaluating them and putting them back in the colors according to their number. But that's the basic idea. So we can add, append, and then remove a child from the container of these divs, each one when a click event happens. So we saw adding and we saw removing. Talk a little bit about altering. So once we have an element in our hand, we can also change its properties, its appearance, its CSS classes, pretty much anything we want. If it's a text, we can change the text. So I think we have quite an elaborate example for that. But I'm not sure this is the one. So that's one example of how this thing works, and there's another one which is more eye-catching. So what do we have? So we have a text box in which the user is entering a student name, I guess, and then we have a link that will add the student to a certain unordered list. And then we have a button that will sort or unsort those students in the list. It will change between sorting and sorting them back. The idea is, again, we're holding some array to reflect the elements that we have. We have the two event listeners, one of them when we click the add and one of them when we click the sort. First, when we click the add, we are creating a document element of list item, setting its inner text to the name, which was given in the text box, and then appending it to the student list, and also pushing it to the array that we have. And note that what we're pushing into the array is an object with certain properties, as we can see here with JSON. First of all, we're putting its index according to the current list length, so that we'll keep track on what was its original index. We're keeping the value, which is the name that the user is entered, and also the item, which basically is a link to the actual item that we've created. So our array contains not just the names and indexes, but also a reference to the actual HTML element on the document. So we're creating the element, we're putting it to the page by appending it, we're inserting a reference to it into the array so that when we want to change things, we can very quickly traverse the array and find the exact node that we were using. So clicking the sort, first of all, changes the HTML of the button between the words sort and unsort by setting their inner HTML. And according to the action, the current action that the button mode is on, if it's we have also another variable here. And here we have two sorting options. One of them will be sorting them by their index. So we are sorting the students' array accordingly. Either by index, we have here two sorting functions. We saw how to sort arrays with a specific sort function. So it will determine whether the two array elements should be sorted or replaced in their positions according to the index that we keep, which is the original index of those. Or, so that in this case, we will revert to the original order of the list items, or according to their value, which is the name. So in this case, they'll get sorted out. And once we have the array arranged in the way that we want to, we are just reappending the students into the list. Has to be some clearing somewhere, which I'm currently missing, but let's see this working. So let's add a few elements which are not sorted. What? Okay, so once we click the sort, we have in our memory an array that represents these elements, both keeping their original indexes, both their text, and also allowing us to reference the actual elements in the list, in the HTML list. So once we click sort, these will get rearranged according to their name, and the unsort will get here, we'll change the button function to unsort. Once we unsort them, we're going back to the original indexes, so the list gets back to the original order. There are ways to also get to the actual element styling. We can change their styling inline as if you have an HTML element with a style attribute, and then you can set it. You don't have to do this through CSS. Of course, CSS is quite important, but we saw last time when we saw the disappearing and appearing ninja that we're actually changing its width property, because an image can be changed directly with the width. But in most cases, if we want to do things right and work correctly, we should use styles. And one way to do that is to change the element class. We can do that by getting the class name of the HTML element. Another way is to get directly to the style properties, which represents the current style that it has. For example, its display or its width. And we'll see an example where we can change the element's position on the page also, so we can let them move around, for example, when we're dragging something with the mouse or not. So as a last thing to see for today in demos, sorry that I don't have any more fancy stuff to show, but next time. Okay, so we have here some basic CSS, quite a lot of it. And we have here some container div, which contains another div. All these get styled according to the CSS above. And we have 4 buttons. One of them will move up, down, right, and left. And we can see, basically, we have a few methods here that handle our button clicks. And basically, we don't do much here. We just get our, we get the moving box, and with a few arithmetic operations, very simple ones that are denoted here. We're just setting its style top, style left, style right or left. So, for example, when we click the up button, we're changing the vertical position, which is this function, which will get the node, which is the actual moving element, style top, and move it up or down according to the direction that we're denoting here. So if we're moving up, we'll just set it to a smaller value. If we're moving it down, we're incrementing the value so that we have it here as a negative or positive, just as a number of pixels, and we're just calculating how many pixels to move it up or down, and we're just moving it from its old position, which will get the style top initial position, parse it as an integer. This means that we're parsing it as base 10 as a regular integer value, and this is the old position, and we're just styling it by changing the top by adding or incrementing or decrementing the top property by 5 pixels up or down according to the direction, and these according to this structure here. So if we have up, we'll get to this property, and we'll get here a value of -1, and we'll move it 5 pixels up. Pretty simple, I think. And the effect is that every time we click those buttons, we're actually moving the element inside by changing its style.
What's happening with the other elements nearby?
What's happening with them?
I mean, they conflicts.
No. This thing is probably, I have to check the CSS, probably positioned absolute positioning. So it just gets coordinates of top and left. So it just moves around. It doesn't affect anything on the other elements.
How if there are two elements in the same position?
So if you have elements which overlap, there's a CSS property called Z-index. I think, first of all, it's about the order that they render. So if the first one renders, then the second one will get on top of it. But they can be overridden by CSS property called Z-index that says which one is actually kept on top of the other. And that's it. So in this case, this box was rendered after the containing box. And you can see that if I go up enough, I'm just going up out of the... Well, this container doesn't really have any effect, but it's always on top of it. I mean, the moving box is always on top of it. So that could be hours of fun. I'll spare you all the possible clickings here. I really meant something more fancy than this, but this one is also...
What happens if you click down and the element overlaps down?
Then I won't be able to click down anymore. But, well, if it does get on top of it, that's it. Great. Yeah. Just a few words about optimization. So, I don't have anything more to say about this one. I think we've already mentioned the appending function. But just to note that the appending function is relatively slow operation. There is a way to, if you're adding a large number of elements to your document, you can do this all at once by creating something called the document fragment. So a document fragment is just a patch of HTML which is outside of your original document that you can manage, and you can append things to it outside of your HTML. It will not be rendered until it's actually appended as it is into your HTML document. So that's one way to add things to your document in a more performant way. So there's a pref. Okay, so there are actually two demos, but one of them that I wanted to show, but actually I have to check why it's what's missing on it, and I again didn't have a lot of time to do that, but I'll just show it quickly. What I do see is quite a difference in rendering time. I've put here a table with two links that don't really look like links right now because the styling changes them. But you can see that I have here, these are actually links. One of them will add elements using a document fragment, and one of them will insert them directly. So the functions here, just counting a number of items, in this case 1,000. And in each side of those tables, on each of those TDs, I have empty lists. And the first method will get the first one. And instead of inserting them directly, I'm creating a document fragment, and I'm appending the children. I'm appending them, or actually, maybe this is my problem. I think I made a small mistake here. So, or maybe not. I have here the document. So this is how I create a document fragment outside of my document. And once I have it ready with a child, I'm appending, I'm cloning it, and I'm adding it as a child to the unordered list. In the other example, I'm just taking and creating an element and appending it directly to the list. I didn't see much of a difference here in runtime. Even when I just appended all the elements directly to the fragment and then appended it. I can change that to show. But the basic idea here is that rendering time is pretty fast on both ends. And if I increase this, we'll see that actually the creation of these elements is still fast, but rendering time is significantly gets slower when I go to the direct insert. So this one was quite fast. So is this one. Let's increase it a little more. So again, 51 milliseconds. And a bit slower here. So now we have a large number. And okay, this is already becoming too slow for it. But if we do it with direct insert, I suspect we'll have to wait more time. Okay, I think I'll kill the browser right now, just not to wait too much for this to render. Let's take a look at this JS performance. So this is pretty much the same thing. We're appending children first of all to the fragment here, and then we're appending them to a bunch of holder elements. Instead, here we're appending them directly to the holder elements that we have on the page. You can take a look here that we have a number of elements on the page, probably created here. Let's try to run this. It's more safe to do it here. And you can see that actually rendering time again was slow until this thing completed, but we can see that we have better performance for the document fragment manages, not by very far in most cases, but to make things faster and more operations per second than regular appending of objects to the document. That's the blue bars here. I think that was actually the document fragment demo that we were just about to see, and maybe I'll show a little bit more of that next time. So every time we append things, things get re-rendered, and that's something that we can do slowly. One way to create nodes more quickly, is to use, instead of creating them once every time again, we actually saw that in the examples, we can use the function called clone node that will take take the document and take your node and create a copy of it, so that it'll have an exact copy of the original one. It works faster than recreating nodes every time yourself. And over here we can see a great example of the letter A. I don't know why, but it's also something. I don't think we have this demo somehow. No, I think we're missing this one. But we've seen the way that we can create elements with clone nodes throughout the other examples. So I'll try to show some more fancy for the finale, which we'll have next week. It'll be too early for beers, but we can maybe think about something. Okay, any questions about what we saw today? All right, guys, so next time we're on Wednesday, and we'll talk about jQuery, and that will be our last session. So see you Wednesday, and thanks. Thank you.